And unfortunately, when this was on the exam worth 5 marks, a lot of people only got 2 marks. And I think they've taken some feedback from this. Now they've added the word in here algebraically, because a lot of people were able to quite quickly guess and check and find the answer. And according to the marking guide that year on the provincial exam, they only got 2 marks. So I'm going to give you some time to write this down, and then we'll go over it. So in the second sentence, write a function v of x to express the volume of the box in terms of x. So we know if we draw a picture of this, we know it has side lengths of x, x plus 2, and x plus 10. So there's a picture of a rectangular prism with those lengths. Write a function of the volume in terms of x. So volume, length times width times height. That was worth 1 mark. And now they want to find all possible values of x given that the volume is 96. So this is where a lot of people lost their marks, because they found out that the answer was 2 just by guessing and checking. I mean, it was non-calculator, so they're not going to give you an answer that's 1.38 on a non-calculator part. So you try 1, 1's not enough, you try 2, it works, you quit, which makes sense. So now they've added this word algebraically. So if you were asked to solve the dimensions of the box algebraically, then just guessing and checking doesn't do that. How do you solve this? Well, this is the part where a lot of people had trouble, because if you want to solve this, the 96 on this side, this is already factored, but the only way you can solve something if it's factored and equal to 0 on one side. So we're going to need to make one side equal to 0, but once we do that, I'm not going to do it yet, you'll have to multiply this out. So if I multiply the first 2 together, I'm going to get x squared plus 12x plus 20. And then if I multiply that x through, I'm going to get x cubed plus 12x squared plus 20x. Now I can bring over the 96 and say, let's try to factor this. Now, when you're trying to factor this, you're looking at that last 96, and you have to say, okay, it could be any of the factors of 96. So 1 and 96, 2 and 48, and probably your times table 96 isn't one of those answers that you deal with often. So it's sort of like, oh yeah, 6 times 16, my 16 times table. No, it doesn't come up very often. So we have a problem here where we've got to plug in numbers. Chances are it's going to be a low number. If you were guessing and checking at the beginning, you might have found out that 2 already worked. So if we make this, if we call this P of x, then plugging in 2, sure enough, gives us 8 plus 48 plus 40 minus 96 is equal to 0. Now, part of the reason we want to solve this algebraically is because guessing and checking shows us that 2 works, but it might be that there are other answers that work as well. By solving it algebraically, you find all of the answers and are able to say for sure what the final answer should be. So once you know that x minus 2 is a factor, what do you have to do to factor this completely? You're going to have to use synthetic division. So we have 1, 12, 20 and minus 96, and we would have a positive 2 out front, bring down the 1. And sure enough, we get a remainder of 0. So now we can say that our original thing that we had, which was 0 equals, we can factor out an x minus 2, and we're left with x squared plus 14x plus 48. If there are other solutions, you will be able to factor this. Now, it doesn't necessarily have to be factorable. This might be done. Right? We did one on the board the other day where the last thing you looked at it for a long time because it wasn't factorable. Is x squared plus 14x plus 48 factorable? Yes, it is. So in this case, it is. We get x plus 6 and x plus 8. And so our possibilities for x are 2, -6, and -8. So there is 3 answers. But now if you look back at the picture of the box that we drew, can you see if the height is x, this doesn't make sense. Neither does this. So our only solution is x equals 2, and then the dimensions are 2 by 4 by 12. Was there centimeters or any units? Centimeters cubed is the volume, so this add in centimeters, centimeters, centimeters. Final exam has a special deduction. You only lose it once, but it's called units. If a question has units and your answer doesn't have units, they will bubble in a special thing saying you forgot your units once, and you'll lose a half a mark once on your exam. If you forget units on 15 questions, you will only lose half a mark once. Okay? That is just on this exam. Okay? And that is only on the exam. So, on my quizzes and my tests, if you forget units 15 times, I'm going to take off a half a mark 15 times to hopefully get it ingrained in you that by the time you get to your exam, you're not going to do that. So on all your quizzes and tests leading up to the exam, every time you make a silly mistake, like not making something equal to 0 when it's an equation, or forgetting units, or forgetting arrowheads on graphs, I'm going to deduct every time so that hopefully by your exam, which is worth 30% of your mark, you're going to be ready to go and not make those mistakes. All right.